So okay, this is all about prism. You saw the video showing the experiment. It was a great experiment actually. So now for prism I have brought the PPT actually. I'll teach from the PPT. That's because if I write it, then the flow will be disrupted. That's why. And now, so prism I have written here. Angle of prism. What is angle of prism? Angle between two refractive angle is called angle of prism, and this is called the refracting angle. What happens is that angle between two refracting surfaces, it will be, okay. Yes, so there is a refractive angle. Now this is the prism, a glass prism, say maybe a quartz prism as well, we don't know, but a prism to be precise. A ray is hitting the surface, is incident on the prism surface, on one surface, and is emerging out of the other. That's why we call this the emergent angle, and this is the incident angle. So here we have 90 degree because this is the normal. Here we have 90 degree because this is the normal to the surface, and this is the line that through which the ray could have gone, along which the ray could have gone, but since it is suffering dispersion, so it will go through this line. Now if you know about the properties of a triangle, you will understand that the three angles of a triangle make 180 degree. They are supplementary. All angles, they make up 180 degree. They are supplementary. And A is equal to R1 plus R2 from here. Because if we see this equation, then we will get is what we will get is that A plus 180 degree minus of whole R1 plus R2 equal to 180 degree. So these will get cancelled and minus to the other side, so it makes up A equal to R1 plus R2. Now del 1 equal to I minus R1. How? Check here. I, this is I and this is R1, so this is del, this is del, so this one is the deviation angle, deviation 1. Okay, great. Now total deviation, we will write total deviation as sum of all deviations. That means deviation 1 plus deviation 2. So it comes out as I plus E minus A. You can see the derivation is here as well. This is a short lecture just as a continuation of the experimental part. So I'll keep it short, and you can just pause the video and check the entire derivation. I'll wait for 10 seconds. Okay, so now graph and formula of the prism. So see, here you can see a beautiful graph showing deviation, angle of deviation versus incident angle. So you see a U-shaped curve here, and at this point you have minimum deviation. At this point you have minimum deviation. At deviation is I plus E minus A. Okay, angle of deviation. Now at minimum deviation, where I is equal to E, R1 equal to R2 equal to A by 2 here. Can you understand? So I equal to E and deviation minimum will be 2I minus A, because I equal to E. Here if we put I equal to E, we can write 2E minus A, 2E minus A, or 2I minus A. If we apply Snell's law, sin I by sin R1 equal to mu by 1, because sin I by sin R equal to refractive index, that is Snell's law. For small angle prism, mu equal to deviation minimum plus A by 2 by A by 2. How did it occur? Check. For small angle prism, we will use small angle approximation. And when you use small angle approximation, you know that sin theta becomes equal to theta when you approximate it. If theta is small, very small, sin theta almost equal to theta. Okay, this is small angle approximation. So from here it has a derivation, but it has not been shown here because it is a video as a continuation, as I said, of the experimental part. So sine del m plus a by 2 by sine a by 2, this is a very important equation and as a derivation as well. You can check it on the internet, or I will just bring the derivation to you if you want it. You can ask in the comments in that case if you want that. But this is the refractive index of the prism. This is the formula of the refractive index of the prism: sine del m plus a by 2, sine del m plus a by 2 by sine a by 2. And if we approximate it in terms of small angle, then we will get del m equal to a into mu minus 1. Going to the next part, we know that now this is the equation, very important equation. We know that refractive index, how do you write refractive index? Refractive index is written by c by v, mu equal to c by v. This is the refractive index. So mu is, that means mu is inversely proportional to velocity of light. But we also know that v equal to nu lambda. So velocity equal to nu lambda, frequency into lambda. That means v is directly proportional to lambda, and that means as a follow up, mu is also inversely proportional to lambda, and that is because v is directly proportional to lambda. So you got the analogy here. Now let's see this dispersion illustration, which I already showed you in the experiment. This is air and this is medium, and this is how, you know, the green light is almost, in this case the green light is almost the point where critical angle is, I mean the ray is, main ray is incident at a critical angle. Now if a white light strikes the prism, just wait a minute. If white light strikes the prism, then you see the dispersion here. I only shown you 3 colors, RGB, 3 colors. Now you can see the deviation of red, and this is the dispersive angle. This is the dispersive angle. Okay, great. And this is how it was done, the experiment. Dispersion through a thin prism. We are using a thin prism here. Try to understand. Thin prism means the refracting surfaces, they are very thin. They're very thin, because otherwise the experiment will have a different conclusion, I mean answer, result. So okay, you have completed the entire prism part as far as theory is concerned, and I will show you these things, the spectrum which you saw in the experiment. Okay, so great, this one you saw in the video itself, and I have brought a screenshot here. So this is violet in this case, and here you can see red. You can also see all the colors here. You can see orange, you can see yellow here, you can see green here, you can see blue here, and you can see indigo here, which is a darkish blue color, and then the light blue color, lightish. And here you have violet, and here you have red. So you can see the entire spectrum here. Actually most of them are not visible. The, I mean green is visible, very green and yellow is prominent here, but red is not that visible. Red and orange are like mixed up, but still the spectrum is clear here. So hope you have understood, and subscribe to our channel and help us grow. This video was in English because there are many international students as well who are seeing the video, and जो हिंदी के स्टूडेंट्स हैं वो सबटाइटल्स ऑन करके देख सकते हैं अगर आपको हिंदी में चाहिए तो, क्योंकि इंग्लिश से जो ट्रांसलेशन होता है वो ज़्यादा एक्यूरेट भी होता है, जो हिंदी से इंग्लिश वाला वो कभी कभी इनएक्यूरेट हो जाता है। तो आप सबटाइटल्स ऑन करके देख लीजिएगा अगर हिंदी में आपको सुनना है या फिर देखना है। तो थैंक यू फॉर दिस शॉर्ट वीडियो अगेन। और अचीवर बैच का लेक्चर जल्दी आएगा, रिकॉर्ड कर रहा हूँ मैं। और yes, this is how it was done. So wait a minute.